sunlight surrenders completely at a depth of 3,000 feet. Beyond this twilight boundary, the ocean plunges into a realm of eternal midnight and freezing waters, continuing downward for miles into the crust of the earth. At the bottom of the western Pacific Ocean lies a crescent-shaped scar known as the Mariana Trench. It is a world where the weight of the water above generates a crushing force capable of imploding solid steel. For decades, scientists believed this absolute darkness was a barren wasteland, a place where the physical limits of biology would be violently exceeded by the sheer hostility of the environment. The silence of the abyss seemed to promise nothing but an empty, watery grave for any organism foolish enough to drift too far from the sun. The sheer geometry of this abyss defies human comprehension. Plunging nearly 7 miles beneath the surface, the lowest point of the trench is the Challenger Deep. If Mount Everest were dropped into this chasm, its peak would still sit more than a mile underwater. Down here, the hydrostatic pressure reaches an astonishing 8 tons per square inch. That is roughly equivalent to balancing 50 jumbo jets on a single human being. The geological forces at play are equally staggering, driven by the slow, grinding subduction of the Pacific Plate beneath the Mariana Plate. In this brutal, lightless canyon, the very chemistry of life is under constant, unimaginable siege. Under such immense force, the fundamental building blocks of biology begin to fail. Extreme pressure forces water molecules into the tiny spaces within proteins, causing them to distort, unravel, and ultimately collapse. Cell membranes, usually fluid and dynamic in shallow waters, become rigid and shatter like glass under the immense weight. The biochemical reactions necessary for basic metabolism grind to a violent halt. How life survives crushing deep-sea pressure requires more than just a thick skin or a slow heart rate. It demands a complete and radical reinvention of molecular architecture from the ground up. Uncovering the bizarre biological secrets of this realm revealed a microscopic miracle. Deep-sea creatures rely on specialized molecules called piezolytes, pressure-stabilizing compounds that act as microscopic scaffolding within their cells. The most prominent of these is trimethylamine N-oxide, or TMAO. As ocean depth increases, the concentration of TMAO in the tissues of deep ocean animals rises proportionally. This vital molecule binds tightly to water, preventing it from forcing its way into the delicate folds of proteins. It effectively props up the cellular machinery, allowing life to function under the immense, crushing weight of the ocean. The discovery of this molecular armor fundamentally shifted our understanding of extreme survival. Researchers found that TMAO is the universal key to life in the hadal zone, the deepest region of the ocean spanning from 19,000 feet to the very bottom of the sea. By mapping the concentration of these piezolytes, scientists realized a profound truth about the limits of biology. The absolute depth limit for complex fish is dictated not by a lack of food, nor by the freezing temperatures, but by the precise point at which a creature's cells can no longer physically hold enough TMAO to counteract the crushing depths without becoming toxic. Armed with this chemical shield, life does not merely linger in the abyss. It actively hunts, scavenges, and dominates. The deep-sea amphipods are prime examples of this relentless tenacity. While their shallow-water crustacean cousins are often no larger than a fingernail, the hadal amphipods exhibit a phenomenon known as abyssal gigantism, growing up to a foot in length. Encased in pale, heavily fortified exoskeletons, these scavengers swarm the trench floor in staggering numbers. They use highly sensitive chemoreceptors to detect the faint chemical trails of carrion falling from the sunlit world miles above, racing to consume any organic matter before it is lost to the mud. Above these swarming scavengers swims the undisputed apex predator of the Challenger Deep. The Mariana snailfish is a ghostly, ethereal creature that looks entirely ill-equipped for Earth's most punishing biome. It lacks the heavy scales, sharp teeth, and armored plating typically associated with deep ocean monsters. Instead, it possesses a pale, translucent, and highly gelatinous body that seems to melt when brought to the surface. Yet this fragile-looking fish thrives at depths exceeding 26,000 feet, navigating the eternal dark with unparalleled, effortless grace. The snailfish's apparent fragility is actually a highly evolved response to the unforgiving physics of its home. Dense bones and rigid scales would be catastrophic liabilities at this depth, easily fractured by the immense pressure. Therefore, its skeleton is made primarily of flexible cartilage, with distinct gaps in its skull that allow its head to equalize pressure internally without collapsing. Its cellular structure is heavily saturated with piezolites, and its metabolism operates at an incredibly slow, deliberate pace. It is a masterpiece of evolutionary engineering, perfectly calibrated to exist where the physical laws of nature actively conspire against survival. Reaching this alien world to witness such adaptations required an unprecedented leap in human courage and engineering. In 1960, the bathyscaphe Trieste, a heavily armored submersible, began its historic descent into the trench. Inside a tiny steel sphere with walls 5 inches thick, 2 explorers embarked on a journey to the absolute bottom of the world. The descent took nearly 5 hours, a slow, terrifying plunge through descending thermal layers, fading light, and steadily rising, catastrophic pressure. The psychological and physical strain of the dive was immense, testing the absolute limits of the explorers' resolve. At 30,000 feet, a loud, sharp crack echoed through the cramped cabin, shaking the entire vessel and stopping the hearts of the men inside. An outer plexiglass window pane had fractured under the sheer, unyielding force of the ocean. The explorers faced a critical, life-or-death decision: abort the mission immediately and flee to the safety of the surface, or trust their engineering and continue into the unknown. Driven by the relentless human spirit of discovery, they chose to descend further into the dark. When the Trieste finally settled into the ivory-colored ooze of the trench floor, its floodlights pierced a darkness that had remained undisturbed since the dawn of the planet. Through the cracked viewport, the explorers did not see the lifeless, barren desert that science had predicted. Instead, they witnessed a flatfish gracefully swimming over the sediment, proving definitively that complex vertebrate life could withstand the highest pressures on Earth. That single, fleeting observation shattered the prevailing scientific dogma of the era and expanded the boundaries of the known biological world. The sediment beneath that historic vessel is a product of immense planetary forces constantly reshaped by the grinding gears of the Earth. The Mariana Trench was born from the violent collision of tectonic plates, where the massive Pacific Plate is being mercilessly dragged beneath the smaller Mariana Plate. This subduction zone is a site of intense geological friction, shaping the ocean floor and creating a massive V-shaped funnel that dictates the flow of deep ocean currents and traps the falling debris of the world above. This geological funnel acts as a massive, inescapable trap for organic material. Dead algae, the colossal carcasses of whales, and microscopic debris slowly drift down from the surface, a phenomenon known as marine snow. By the time this sparse biological fallout reaches the hadal depths, it has been picked over by countless other hungry mouths in the water column above. The life forms at the absolute bottom must survive on the final, degraded dregs of the ocean's biological production, making every meal a rare, vital, and fiercely contested event. To exploit this incredibly sparse nutrient supply, some organisms have abandoned complex multicellular bodies entirely. Xenophyophores are giant, single-celled amoebas that can grow to the size of a human fist, a biological absurdity in any other environment. They construct delicate, intricate shells from the surrounding sediment and the microscopic glass skeletons of dead sea sponges. Rooted firmly to the trench floor, they cast a wide, invisible net of protoplasm to absorb whatever organic matter the slow, freezing currents bring their way. These giant, single-celled organisms are also master chemists of the abyss, harboring secrets that continue to baffle researchers. Scientists have discovered that xenophyophores accumulate incredibly high concentrations of heavy metals like lead, uranium, and mercury within their bodies. How they survive this highly toxic payload, which would be instantly lethal to surface life, remains one of the great, unsolved mysteries of deep-sea biology. They stand as living laboratories, holding secrets to cellular resilience and heavy metal resistance that could eventually revolutionize human medicine and biotechnology. The extreme pressure, toxic accumulation, and absolute isolation of the trench have created a unique, hyper-specialized evolutionary crucible. Species trapped within this deep-sea canyon are entirely cut off from the rest of the global ocean, separated by vast underwater mountain ranges and insurmountable pressure barriers that prevent migration. This intense isolation drives a rapid, bizarre divergence of species, turning the abyss into an engine of biological novelty where unique forms of life exist nowhere else on the planet, evolving in complete darkness. The deepest scar on Earth is not a graveyard, but a hidden sanctuary of unparalleled endurance. The ghostly snailfish, the giant amphipods, and the microscopic piezolytes all tell a unified, awe-inspiring story of survival against impossible odds. They prove that life does not retreat in the face of crushing pressure, toxic chemistry, and eternal darkness. Instead, it adapts, it endures, and it thrives, waiting patiently in the silent depths for the next beam of human light to uncover the full mystery of its magnificent secrets.